Okay, this last slide is about when to use supervised learning regression problems. Well, when we want to predict a behavior, and this behavior is reflected in a variable, in the target variable, and this target variable is numerical. When we want to study the association between a set of predictors and a numerical target variable, it is also the case that we want to use regression methods. But to answer that, whether we should use mean absolute error or root mean square error, which one is better? Well, there is no better and worse. It depends on your problem, on the convention of the firm, domain, and so on and so forth. Sometimes you might want to go with mean absolute error, you might want to go with root mean squared error. There is a technical difference between these two. Mean absolute error is more straightforward for interpretation. It's very easy to interpret this value. It is the average distance of predictions from the target. That's all. Root mean square error is a little bit less straightforward to interpret. But there is more important thing about root mean square error. Root mean square error penalizes the larger error. It gives more weight. So it gives more weight to larger errors. Why? Because of that squared element. So if your error is 100 and then one of them is 10, on the mean absolute error, it would be 110 over 2 equal to 55. But what about on root mean square error? Well, this 100 would be 10,000, and this one would be 100. So 10,100 divided by 2, it would be 5,050. And then if we do the calculation for 5,050, it would be something around 74. Okay, so the higher the values of mean absolute error or root mean square error, the higher the value, the worse is our model. So the lower the quality of learning. And therefore, for this example, you can see that RMSE weighs up the larger errors. It is more sensitive to the larger errors. And sometimes you want to be very sensitive to large errors. Sometimes it doesn't matter whether you are 100 units far from the actual value or 50 or 10 on aggregate, in the meaning that 100 units far from the actual value is actually equal to is actually twice as bad as being 50 units far from that value. Okay, so it's linearly increases, but RMSE actually highlights and gives more weight to the larger errors. It's more sensitive. Sometimes in your problem you might be more careful about larger errors. And this is the difference between these two metrics. We will learn more metrics, and they would have different characteristics and features suitable for different situations.